All right, so now to when we're looking through a triangle, we've gone through how do we find the hypotenuse given two legs of the triangle. But what about if we're given the hypotenuse and we have to find the other leg? So we're given one leg and one hypotenuse. This little video is going to go through how do we solve for those. So let's get started by taking a look at just a little bit of an example here. So to find the hypotenuse using the two legs of the triangle involves, again, so if we're trying to find the hypotenuse, we use the theorem directly. Okay, so we're going to go through and we're going to do it exactly the way it shows. A squared plus b squared equals c squared. Now, if a leg of a triangle can also be found if the other leg is known as well as the hypotenuse. Okay, so if we know one leg and the hypotenuse, we can solve for the other leg. Now, if the hypotenuse as well as leg A is known, we need to manipulate it a little bit. So what we're going to do is we're going to subtract. So to get B all by itself, we're going to subtract A squared from both sides. So part of algebra is being able to manipulate formulas. So if I subtract A squared from this side and I subtract A squared from this side, okay, I'm actually going to get B squared all by itself. A squared minus A squared cancels out and gives us 0. And what that means is that on this side here, we're going to have B squared, and on the other side, we're going to have C squared minus A squared. And so now we can be able to solve for what is side B. Now again, same as when we try to find C, we have to take a square root. Here we're going to have to do that as well. There is another way to kind of rearrange this and organize this or write it, and some of you might find this easier. But to find B, we can take the square root of C squared minus A squared. And so we could just take the square root and that would give us A as well. But then we have to kind of use brackets and make sure we solve there. We might as well solve this and then take the square root afterwards. Now, if the B side is known instead of the A side, now again, remember B and A can be flipped around. We don't one or the other, it doesn't really matter. We can just flip this around and this is then A squared is equal to C squared minus B squared. Okay, so we flip that around and we can do the same thing here. Just flip flop the A and B. It really doesn't matter. They are completely interchangeable. So let's do a little bit of an example here. Okay, so here we have a triangle, right angle triangle. Hypotenuse is 13 centimeters and this leg is 5 centimeters. You may recognize this one from the previous lesson or the previous example there where we actually had 5 and 12 and it equaled 13. So now this side should equal 12. And let's go through how we know that for sure. All right, so let's label to start with. We're going to label that as C. This one is going to be B, and this one is going to be A. And so we're going to rearrange our formula here a little bit, or we're going to use the rearranged formula. And we're going to do B squared is equal to C squared minus A squared. So very important that we subtract. If we start adding, we're going to be getting that B is way bigger than C, and that cannot happen because C has to be our biggest side. It always has to be the biggest side. All right, going to plug in the values that we have here, and again, I'm going to be using the units because we have units on this one here. So C is 13 centimeters, and we're going to subtract 5 centimeters, and we're squaring both of those. So this is B squared is equal to 13 centimeters. Oh, that's not 13, that's 169 centimeters squared minus 25 centimeters squared. And that means that B squared is equal to 144 centimeters squared. Now again, I'm going through these pretty quickly. These are all nice perfect squares. They're numbers under 20, so we should be able to do them without too much calculator work. All right, now that we have this here, now we need to get B all by itself. And so we need to take the square root of B squared, and we need to take the square root of the other side as well. We have to do that, otherwise it's gonna, again, this can't be 144. So what that's gonna give us then is that, let's see if I can get a text box going here. There we go. Is that B is equal to 12 centimeters. So that means that this side is 12 centimeters. Again, this is a nice Pythagorean triple. We have really nice numbers that we are using in this case. Now, when we are doing this, again, be sure to take the square root of the answer. Just like we did here, we got an answer of 144. Take the square root, that's actually our side length. It's not, the side length is not the that whole squared one. We have to take the square root to solve for it. All right, let's do two more examples. So in this one here, again, hypotenuse is C. This side I'm going to give A, and missing side is going to be B. And so our equation that we're going to use is B squared is equal to C squared minus A squared. Now, when you are doing this equation here, the C is always going to come first. The C is always subtracting either A squared or B squared. So we'll make sure that C always comes first. Plug in the numbers that we have. So C is 9 minus A, which is 3. And so we have B squared is equal to 81 minus 9. Therefore, B squared is equal to 74. Oh, sorry, that is incorrect. 72. There we go. All right. Now we take the square root of B squared and we take the square root of 72. And if we think about that, 72 is kind of right between 64 and 81, almost right between. So we're probably looking at something around 8.4, 8.5 roughly. So let's use the calculator for that. So far, I've been able to do things without the calculator, but in this case here, we're going to use the calculator. Square root of 74 equals 8.6. Huh. Oh, sorry, I did that wrong. Square root 72. I'm using 74 again. There we go. 8.48. 8.49 would be our answer. So 8.49 is our answer. Therefore, side B is 8.49. It is smaller than 9, so that's good. We need that. Not much, but it is smaller than 9. All right, last one here. Again, hypotenuse is C. This side I'm going to call B in this case, arbitrarily. And this one here is going to be A. In this case here, we're trying to solve for A. So now instead of using B squared, we're going to do A squared. Again, it equals the same thing, minus B squared. You'll notice that in this case here, I have the B is after the C, right? So it's always C minus A or C minus B every single time. Plug in the values that we know here. So C is 6.4, so it's a 6.4 squared minus 5.6 squared. And in this case here, A squared is equal to, I'm going to use a calculator to solve for this one here. So 6.4 squared minus 5.8 squared. Oh, that was 5.6 squared. Oh, every time I hit you. And we get 9.6. Okay, so we get 9.6. We need to take the square root of both sides again. And again, this is every time. Okay, so every time, once you get an answer, we take the square root. And I'm just going to change that to a different color. And so I have this here. I'm going to do square root of my answer. On your calculators, you can probably just hit square root. And we get 3.09, well, 3.10. So our answer is A is equal to 3.10. That would be our final answer. Again, it is smaller than 6.4, so that's important. And then A and B, again, are completely arbitrary. So that is solving for a leg using the hypotenuse and another leg.